Hi guys, we're Group 4 Zinc of grade 12 Udin, and now we're going to discuss about intermolecular forces. Have you ever wondered why solids and liquids are liquids? I can imagine like a solid would just burst into oblivion at stable conditions. Like, isn't it actually odd to happen? This is where I talk about intermolecular forces. And just a reminder, this is not the same thing with chemical bonding forces or intramolecular forces. So basically, intermolecular forces are what keeps the particles on their physical state, whereas intramolecular forces are what keeps the actual particles together. Okay, with all those things said and done, let's talk about the 4 different kinds of intermolecular forces.
London dispersion forces, named after Fritz London, who discovered them. London dispersion forces are the weakest intermolecular forces. This is most commonly seen in weak interactions between two nonpolar molecules, but it is still evident in all matters. They are also called as instantaneous dipole to induced dipole, attractions between of its temporary interactions due to the asymmetrical distribution of electrons. Shape, size, and surface area are the main factors in determining the amount of London forces that are present between the particles. One example is the interaction between noble gas, helium, and its other relative atom.
Hey guys, today I'll explain dipole-to-dipole bonds. So first things first, what is a dipole? Di comes from the Greek word dis, meaning two. So dipole literally means having 2 poles. Polar molecules have a partially negative end and a partially positive end, much like a magnet's south and north end. When a polar molecule's partially positive end is close to another polar molecule's partially negative end, they form a dipole-to-dipole bond. It is weaker to both ionic and covalent bonds, which is why they are represented by a dashed line instead of a straight one. The bond only forms when 2 polar molecules' opposite ends are close together.
Now we will talk about hydrogen bonds. What exactly is a hydrogen bond? It is actually a special type of a dipole-dipole attraction when a hydrogen atom bonded to a strongly electromagnetic atom or a lone pair. Like for example, elements like fluorine, nitrogen, and oxygen. Just a reminder, it's a misnomer, not an actual chemical bond. It is a very specific case of a dipole-dipole, as the hydrogen atom is the distinct particles that initiates these unique intermolecular forces. Donors and acceptors from between the bonds are observed in this attraction. Example of hydrogen bonds are ammonia and water, and the nucleotides of our own DNA.
Among the 4 different intermolecular forces discussed in this vlog, the ion-dipole attraction is the strongest force to consider. It involves an ion, either a positive ion, cation, or a negative ion, anion, interacting with a polar molecule. It can also be observed in solutions such as salt water. The positive sodium and the negative chloride is attracted to the polar regions of the water molecule, which is a good demonstration of the ion-dipole forces.
According to the definition, most non-polar molecules have London dispersion forces. To give examples that can be found at home, at our home specifically, it can be found in chlorine, Cl2, and ethyl alcohol, C2H5OH. Due to its non-polar trait, chlorine and ethyl alcohol's molecular attraction force lands in London dispersion forces. Hypochlorous acid, HClO, and water, H2O, are examples at home which follows dipole-to-dipole force. It attracts between positive end of one molecule and the negative end of another molecule.
Another example is ice, wherein the intermolecular force present between millions polarized water molecules that it has is hydrogen bonding. Basically, since it contains so much bonds, a highly electronegative atom bonded with a hydrogen atom. The lone pairs of oxygen atoms strongly attracts the positively charged hydrogen atoms that it really forms a covalent bond, which is why the interaction between molecules in an ice is significantly stronger than an ordinary dipole-dipole interaction. Lastly, the interaction between sodium chloride over salt and the water produces ion-dipole forces. Essentially, Coulomb's law can be observed when the sodium and chloride ions interact with the polarity of water molecules, also resulting in salt dissolution.
In conclusion, we understood in this video about the intermolecular forces and its 4 different kinds. Intermolecular forces are the attractions that are between an atom or molecule with each other, which can attribute to its temperature points, molar masses, and its physical states. Number 1. London dispersion forces are the weakest, found in almost all particles or between nonpolar molecules. Number 2. Dipole-to-dipole forces are quite moderate and are observed between polar molecules. Number 3. Hydrogen bonds are special case, is when a hydrogen atom is paired with a lone electron or an electronegative particle. Number 4. Ion-to-dipole forces are the strongest due to the interactions of an ionized particle and a polar molecule. We now realize that there is a difference between the chemical bonds and the intermolecular forces, as chemical bonds are between the direct trade for the stability of electrons under octet rule, whereas the intermolecular forces are on the interactions and attractions between particles due to their polarities. It must be understood that the changes in particle size, shape, polarities, etc. are vital for the magnitude of these intermolecular forces.